This lesson is for FST, lesson 6.1 on probability. Most likely you will only need a baby calculator when you do this lesson. If you have a graphing calculator, you can use that as well, but you won't need one. Just some real basic things I want to cover right away at the beginning. When you're working in chapter 6, you need to know how many cards are in a standard deck, not including the jokers. So hopefully students are aware of the fact that there are 52 cards in a standard deck. If you're not real familiar with playing cards, you might want to pull out a deck and take a look, kind of shuffle through them a little bit. Know that there are 4 different suits in a card deck, and the suits are hearts, diamonds, spades, and clubs. 2 of those suits are red, 2 of them are black, so students just need to be able to identify those pieces of a regular card deck. When we're talking about a die has 6 sides, just like a cube. And just a quick distinction for students, die versus dice. Die means 1, dice means usually more than 1. For this class, for the most part, we're going to talk about dice meaning 2 dice. Keep in mind that it might mean more than 2, but for the most part you can assume that they're talking about 2. In class, I want to just make real clear to students that sometimes I interchange or mistakenly say die when I mean dice or vice versa. So if you're ever unsure if I mean that we're rolling 1 or 2 dice, please just ask me to clarify. But technically die should be 1 and dice should be 2. Also, the next 4 words here, sum, difference, product, and quotient, those might come up on occasion during chapter 6, and students need to know what those words refer to. Sum is the answer to an addition problem. Difference is when you're subtracting. Product is when you're multiplying, and a quotient is when you're dividing. So know that students will be required to know those words for tests and quizzes. They're words that I'm assuming are words that you're comfortable with. Specific to chapter 6, there's some vocab that we're going to look through here. Probability is just the study of chance. Later on here, we do probability of a specific event as measuring the likelihood that that event will occur. The chances or the likelihood, those are kind of interchangeable ways of describing probability. In this class, when we talk about an experiment, we're not talking about anything formal like you would in your science class. There's going to be no lab notebooks or anything like that. We're just talking real generally when it's an experiment, we're talking about a situation that has several possible outcomes. Since that definition includes the word outcome, let's make sure we know what that means. An outcome is just the results from your experiment. What are the things that you're expecting to have happen? And so those are just kind of the ways we're going to describe the elements of finding probability in a certain situation. The one main vocab word for today, or for this lesson, is sample space. And that's the one that students need to really focus on and practice in this lesson. Sample space is the set of all possible outcomes when you're doing your experiment. So it's very important for students to make sure that they list or know what all the elements are in a sample space, or at least how many elements there are in that sample space. And we're going to practice that here in this lesson and also in the assignment. Just to be real clear here, most people have a basic and general understanding of what it means when something is fair. When our book talks about things that are fair or unbiased, they mean specifically that the sample space has n outcomes and those outcomes are equally likely as each other. So know that probably your working definition in your brain about what fair means is going to apply here as well, but specifically we're talking about outcomes that are equally likely. Outcomes that are considered fair will occur randomly or at random, so that's also included in their definition. So let's get into specifics about how you're going to create events or outcomes and how you would identify a sample space. Let's start with the nice, real easy one here. Tossing a coin. When you toss a coin, one of the event or the outcomes that you could get is, for example, landing on heads. Obviously, there's another outcome there. It could be landing on tails. So when we're listing out the sample space here, we would want to list both of those. So we'd say landing on heads or tails. So both need to be listed when we're talking about the sample space. If they ask us to write an event or an outcome, we would only need to mention one of those. Let's get a little bit more technical now and let's look at rolling a die. An event here could be landing, rolling a 1, rolling a 2, rolling a 3, and so on. But you could get a little bit more creative here and say when you roll a die, one event that you could record or track would be rolling an even number. But when you list out the sample space, even is not going to be one of the outcomes that you're going to write. You're still going to list all the different sides of the die because that's how many different outcomes there are in total. So when you're rolling a die as your experiment, the sample space of that is going to be rolling a 1, 2, 3, 4, or 5, or 6, excuse me. But know that your event doesn't have to be specifically one of those items. Now, one question there would be, could you say that the sample space was rolling an even or an odd? That would imply that there are only 2 outcomes in the sample space, which is not true. So you'd want to be as specific as you can, listing out all the items in the sample space. And let's try one more here. Let's talk about drawing a card from a deck. An event here could be drawing an ace, or drawing a 2, drawing a 7. You can even get more specific and say drawing a 7 of spades, drawing a queen of hearts, or any of those outcomes would be okay for you to list here. When you list the sample space, however, know that there would be 52 different outcomes that we would need to list individually. Obviously, we don't have room to do that here on our paper, so we're just going to kind of start the list here and then go from there. So we can start out by saying drawing an ace, 2, 3, 4, and so on. Keep in mind that you'd also want to list something like drawing a jack, queen, king, and you'd want to list all of the different suits as well. So you'd want to say an ace of spades, ace of hearts, ace of diamonds, and so on. Since we don't have the room to do that, we're just going to assume that those items are assumed for now. Let's get into probability. I know that most students have a pretty decent and adequate definition of probability that they can figure out on their own and probably do probability without any kind of help from me or any kind of help from the FST book. What I'm trying to do in this lesson is try to help you manage the homework and manage how the book wants you to do probability. It's basically just me coaching you through what all the symbols mean in the FST book as it relates to probability so that you can be successful on the probability questions that we have. They're going to be very similar to what you're used to, but some of the symbols may be brand new to you. So we're just going to go through that. Probability of an event is again measuring the likelihood or the chances that an event will occur. And then in quotes here I have listed the wording that you would use to describe the symbols that are here in the formula. So the probability, that's the P, of an event, that's the E, is the number of times. Number of times represents the letter N here. So you're just going to replace this with a number. So it's number of times that event occurs, and you would divide it by the number of items in the sample space. So the E stands for event, P stands for probability, N is always number of times or number of items, and then S is sample space. Notice that the probability is set up as a fraction, so typically that's the way you're going to give your answer is in fraction form, always making sure that that's in lowest terms, of course. But know that you could also give your answer as a decimal or a percent. If you do give it as a decimal or a percent, make sure you round it to whatever is appropriate. So most kids will probably do their probability problems in fraction form. Just make sure you always put it in lowest terms. So let's look at a specific problem from the homework. If a person guesses randomly on a question that has always, sometimes, or never as the answers, and the correct answer is always the word always, list what the sample space would be. Remember that the sample space is all the possible outcomes. So the outcomes here are these 3 choices that they give us. Always, sometimes, and never. Those are the only possible outcomes in the sample space. So they're not asking you to give how many, they're asking you to list them. Describe the event getting the wrong answer. Since always is the correct answer, that means sometimes and never are the wrong answers. So again, they're asking you to describe them or give them or list them. Now when you get to choice C here, they say, what is the N of getting the wrong answer? The n represents the number of times. So the number of times or the number of ways that you could get a wrong answer. Now we're going to count how many answers we gave in part B. So there's two ways we could get the wrong answer. So sometimes they'll ask you to describe what those are, sometimes they'll ask you to count them. And then our final question here, what is the probability of getting the wrong number? We would take the answer that we got from C, that's the top of the formula, and then we would divide by the total number of items in the sample space. So we'd go back to choice A and we'd look at how many things we wrote there in our answer, which was 3. So 2/3 is the probability of getting the wrong answer. Now most students wouldn't have needed the formula to figure that out. You could have just looked at this problem and known the answer. The point here on this question was to help you get comfortable with using the formula to help you answer the question. It's also good practice for the different steps in the process. Let's continue on working with die now. If we work with one die and we talk about the probability of rolling an even number, hopefully students know that that means we're going to say how many ways can we get an even number on the top, so that would be 3, out of the total number of items on a die in the sample space is 6. Now 3 out of 6 is a perfectly fine answer, but it needs to be reduced to lowest terms. So final answer there would be a half. If you said 50%, that would also be, of course, appropriate. Now let's move into rolling 2 dice. 2 dice is implied here in the word sum. Since it's the word sum, we would have to add things together, so you need at least 2 dice in order for there to be a sum. So we're going to be adding the 2 dice together and we're looking for even outcomes. So there's a picture here of all the different outcomes if you roll 2 dice. Hopefully students know or could count here real quickly that there are 36 total outcomes when you roll 2 dice. Keep in mind that when you roll a 1 and a 2, that would be a different outcome or counted as a separate outcome from rolling a 2 and then a 1. So those outcomes are counted as individual outcomes and they are separate from each other. So that's why there's 36 outcomes here for rolling 2 dice. So let's go through and look at where the even sums would be. So I've got 1 and 1. If I add those together, I do get a 2, which is even. So I'm going to mark that one. So I'm just going to go through and start marking all the even sums. And I'm starting to notice a pattern here that it is every other one. So I'm going to speed up here a little bit and go, oh, okay, every other one. So that means 18 are even sums out of the 36 possible outcomes. Now I know that that's going to end up being half, so I don't really have to reduce that fraction because I already know it's half of the outcomes. Let's compare that to the next question, which says rolling an even product. Remember, students, that product means you're going to be multiplying. So we're going to mark the list of outcomes again, but this time in a different way to look at the products. So 1 times 1 is 1. That's an odd number, so I'm not going to mark this one. 1 times 2 is even. 1 times 4, 1 times 6. Looks like it might be every other again. Now let's go to the next row. 2 times 1 is 2, so that's even. 2 times 2 is 4, that's even. 2 times 3 is 6, that's even. And so it's looking like that entire row is going to be an even product. Let's see what happens in the next row. 3 times 1 is 3, that's odd. 3 times 2 is 6, that's even. 3 times 3 is 9. 3 times 4, okay, we're doing every other again. So I wonder if this whole row is going to end up being even again. 4 times 1, yep. 4 times 2, yeah. So what I'm noticing here is the pattern. I'm also noticing that anytime there is an even number present, we get an even product. So let's talk about what that's going to turn into for us. So this row has all 2's at the beginning, so those are all going to be even. This one has all 4's at the beginning, so that's going to be even. Obviously down here, those all have a 6, so those are all going to be even products as well. So then let's talk about why these other ones also work. If you look at the columns now, whenever there's a 2 or a 4 or a 6 as the second die, those are also going to work. So I'm going to circle all of those as well. So if I talk about all the ones that I've now circled in blue, I got 3 rows, which would be half of the items, plus 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 18 was half plus another 9 is going to be 27 of them that are even products out of the total 36. If I reduce that fraction, I'm going to get 3/4. Moving on now to some more general items as it relates to probability. If you're working with the probability of an event and your answer is a 1 or a 100%, that means that that event is certain to happen, something that's guaranteed to happen. So the book might have you exploring some possible events that might have a probability of 1 or 100%. In contrast to that, what is the probability that an event has a probability of 0? What kind of an event would that be? If the probability is 0, that means it's an impossible event. So something that's certain not to happen. So those two are kind of opposites of each other, and the homework may have you explore those possibilities. I want to be real clear with students when you're asked to list outcomes, particularly when you're trying to find all the items in a sample space, there are some very particular ways that you're going to need to do that. First of all, you could make a tree. It's called a tree because it's got branches in it, not because it looks like a tree. Keep in mind that your tree must be aligned either horizontally or vertically. So as you see here in the tree that I've made for listing out the outcomes for tossing 2 coins, start with coin number 1, and I list out the possibilities there, heads or tails. From the first outcome, there are 2 outcomes that could branch off of that for coin number 2. So if I get heads first, from there I could get heads or tails. If I got tails first, from there I could get heads or tails. So notice here that my tree is lined up horizontally, and the outcomes are now listed if I connect all the branches. So I've got one outcome there of heads heads, got an outcome here of heads tails, an outcome here of tails heads, and an outcome here of tails tails. So you could also just make a straight up list if you wanted to, but I know for some kids the tree is helpful because it sets it up visually. Know that you could also set up your tree vertically, and so I'd accept either option there. Again though, we've got things that are lined up vertically. And I'll show students later an example of a tree that's not lined up correctly that would lose points. So I'll show you what that outcome would look like. So I want students to take a moment right now and attempt this question here on their own. List all the possible outcomes for tossing 3 coins. Pause the video and give that a try on your own. So notice here I've made a list. That's another possible thing that you could do to find all the outcomes. So I start out with all the coins being the same, heads, heads, heads. This is coin 1, coin 2, coin 3. So I've got heads, heads, heads. Now I'm going to introduce one change. So I want 2 heads, 1 tails. So I'm going to put the tails in all of the 3 different positions of where the coins exist. So in the first spot, second spot, third spot. So all heads, and then I've got 1 tail introduced. Now I'm going to take those 3 and I'm going to reverse the process. So instead of 1 tail, 2 heads, I'm going to do 2 tails, 1 head. And I'm going to put the head in all the different positions as well. So notice here I've got 1 head in the first, second, and third positions. So the only thing that's left now is all tails. At this point, students get to a point where they say, you know what, that's all great, but how do I know that I've exhausted all the possibilities? One way you know is if you're really thorough in your setup and you really think through where you're putting your heads versus your tails. And then later on in the chapter, we will learn how to determine the total number of outcomes. One quick tutorial on it, even though you don't need to know it right now. The first coin has 2 possible outcomes, so does the second coin, so does the third coin. So since it's 2 times 2 times 2, that ends up being 8 possible outcomes, and that's what we have. 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So I know that I've got them all because I figured it out mathematically, and we will learn that in a later lesson. If we take the tree that we did on the previous question and want to turn it into a 3-coin tree, all we would do is take the ending outcomes and we would just branch off from all of those. So we've got heads, heads, and then we'd have heads and tails, heads and tails, heads and tails from there. And so that's what you get here when we do this tree. Again, keep in mind this tree is nice and lined up. This tree is not. So this person tried to kind of make it creative, make it look more like a graphic organizer, and those trees will not get full credit. It does have a correct answer in that you can find all of the outcomes there. Actually, it should be like that. That's an outcome, but it is not properly aligned, so this one would not get full credit, even though the answer is clearly visible. So students do need to be real careful there. Our last topic here is relative frequency. Relative frequency is calculated the same way that probability is. The only difference obviously will be that they'll use RF instead of a probability. The event that you're recording your relative frequency for means that you're actually going to physically take a die and roll it, or take a coin and flip it, and you're going to record your results. So if I ask you to record flipping a coin and landing on heads. Now we know that the probability of landing on heads for a coin is 50%, but the relative frequency when we actually flip a coin might not be that number. So if I ask you to flip a coin 50 times, 50 is going to be your sample space, and then you would record on a piece of paper how many times you got heads when you flipped it. So let's just say, for instance, you took the coin, you flipped it, you recorded your results, and you got heads 12 times. Your relative frequency then is going to be that fraction reduced to lowest terms. Keep in mind that we would expect it to be somewhere around 50%, but in real life, the relative frequency and the probability may not match.